Welcome to This Explainer. Today, we're essentially building your ultimate mathematical toolkit. We're going to take a really cool journey of mathematical progression together. We'll start off by solving single equations, then we'll scale things up to ranges of numbers, and finally, we're going to decode some pretty complex series. So whether you're just brushing up on your skills or you're looking for that big breakthrough moment of clarity, we're going to lay this all out visually for you. Here is our agenda for today. 1. Solving quadratic equations. 2. The rules of inequalities. 3. Solving simultaneous equations. 4. Patterns, sequences, and series. And 5. Understanding sigma notation. Section 1. Solving quadratic equations. Let's dive right into this baseline tool. Okay, so to solve a quadratic, we always follow a really specific set of steps. It all starts with getting our equation into standard form, which basically just means we have to equate it to 0. Now, why do we do that? Well, because it unlocks the zero-factor law. Think about it. If two things multiply together to equal 0, one of them literally has to be 0, right? From there, we just factorize or identify our terms, solve for x, and if we need to, we test our roots. But sometimes the numbers just don't play nice. And when you can't easily factorize to find exact roots, you pull out the heavy artillery, the quadratic formula. By simply plugging in your a, b, and c values from your standard form equation, you totally bypass all the mental gymnastics of factorization. It gives you the exact roots every single time, even if they happen to be crazy long decimals. Now, when we're handling surds or radicals, the logic is actually pretty simple. You isolate the radical, and then you square both sides to shatter the root. But listen, the absolutely crucial point is this final step. You must test your final answers back in the original equation. Squaring both sides of an equation can actually create invalid or kind of like phantom solutions that simply don't hold true when you plug them back into the original setup.
Section 2. The rules of inequalities. Let's raise the stakes from single answers to entire ranges of numbers.
So inequalities operate a lot like regular equations, but they have some strict, non-negotiable rules for their signs. Adding or subtracting values, that won't change the balance at all. But the absolute most important rule to memorize, the one that literally always catches people out, is this last one. If you multiply or divide across the inequality by a negative number, you absolutely have to flip the sign. Less than becomes greater than, and vice versa. It's a real game changer if you forget it. And when you're plotting these critical values on a number line to visualize your solution, well, notation is everything. We use an open circle if a value is strictly less than or greater than. That basically means we get infinitely close to that number, but we don't actually touch it. However, if your sign includes or equal to, you lock that value right in with a solid closed circle. By testing our critical values, we can actually map out our regions. If we pick test values before the first critical value, right between the two, and then after the second, we'll often see the resulting mathematical signs oscillate. For instance, they might go from positive to negative to positive. It's kind of like a map. Depending on whether your original inequality was looking for values greater than 0 or less than 0, you simply select the corresponding regions on this map to get your final answer. Section 3. Solving simultaneous equations. Let's see what happens when we introduce a second variable. Right, so when you have two unknown variables, you're going to need two equations to find them. The trick here is visual and structural. First, pick the simplest equation, definitely the one without squared terms if you can. From that, you derive a third equation by isolating a single variable, making it the subject. Then you just substitute that newly isolated variable right into the second, more complex equation. And boom, suddenly you're back to solving a single variable equation just like we did in step 1. Once you have that answer, you just plug it back into your simple equation to find the other variable. Section 4. Patterns, sequences, and series. Let's transition to analyzing continuous, predictable patterns of numbers. Number patterns generally fall into two main categories. Over on the left, we've got arithmetic sequences. These are built by a common difference. You're simply adding or subtracting the exact same number to get from one term to the next. Easy enough, right? Then on the right, we have geometric sequences. These grow or shrink by a common ratio, meaning you're multiplying or dividing by the same constant every single time. Recognizing which engine is driving your pattern is really the very first step to decoding the whole thing. Then, we step up to quadratic sequences, which honestly add this beautiful layer of depth. Notice how the pattern works in layers here? A quadratic sequence doesn't have a constant first difference. Instead, if you find the differences between the terms, those differences actually form their very own arithmetic sequence. It's kind of like an onion. It's only when you take the difference of those differences, the second difference, that you finally hit a constant number.
Section 5. Understanding sigma notation. Finally, let's demystify a symbol that often terrifies students upon first glance. Sigma notation. I know it looks like ancient Greek, well, mostly because it is. But mathematically speaking, it's really just a neat, highly concise shorthand way of telling you to add up a specific series of terms. Rather than writing out this massive, huge addition problem that spans an entire page, sigma compresses the whole shebang into one neat visual block. Let's break down exactly how to read it because it's essentially just a loop instruction. The bottom number? That's your start point, the first value you plug in. The formula sitting next to the sigma tells you exactly what to do with that number. Once you calculate that first term, you just increase your starting number by 1, plug it in again, and get your second term. You just keep doing this until you hit the top number, which is your endpoint. Finally, the sigma itself just says, hey, take all those answers you just generated and sum them all together. From standard forms to number lines, from isolating variables to summing up massive patterns, math is a continuous, incredible progression of tools that brilliantly build upon one another. You now have the foundational toolkit to not only solve equations, but to truly understand the logic behind them. So I'll leave you with this thought. Now that you've mastered these core concepts and you can actually see the patterns hidden in the numbers, what complex real-world puzzles will you decode next?